Hi, in this lecture we are going to discuss Introduction to Wireless Communication. So before understanding wireless communication, quick recap we will see how a wired communication takes place. Wired communication, the communication takes place with 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. So both there is a sender side and receiver side. This is the network, that is the communication interface. So if you see working of YSA layer, so each layer works with different patterns. So physical layer operates in bits, that is it mainly deals with hardware for sending and receiving streams on a carrier. So example protocols used are USB, Bluetooth. In data link layer it operates in frames. So examples of how the functions are error detection, flow control. The protocols used are ATM, frame relay, PPP. Next, in network layer, the data, that is the bits, the frames are converted as packets. The functions are addressing and routing the packets from sender to receiver. Various protocols used are IPv4, IPv6, IPsec, ICMP, IGP, EGP. And transport layer, the packets are segmented into small uh, pieces. We can say it is a fragmentation. So the functions of transport layer is segmentation, acknowledgement from both sender to receiver, sequencing means numbering the packets, and duplicate detection. So the main protocols used are TCP and UDP. The finally, the session layer, presentation layer, application layer. So these are deals with the data. The session layer initiates and terminates a particular session. That is when to start the transmission, when to stop the transmission, like that. The main protocols used are PPTP, SIP, SAP, NetBIOS. In presentation layer, it mainly deals with encryption and decryption of the data, security purposes. The protocols used are SSL, TLS. The application layer, it is the human machine interface layer. Means that it connects with humans. The protocols which are operates are HTTP, FTP, SMTP, DHCP, Telnet, like that. Various protocols are used. So if we talk about wired communication, one more methodology is used for communication, TCP/IP. So TCP/IP and OSI, so both are working with the wired communication. So if you see TCP/IP, it operates with 4 layers. So in if you see from bottom, the network access layer combines data link layer and physical layer of TCP OSI model. Then internet layer, this layer works according to network layer, that is sending and receiving of packets. Transport layer, so transport layer works with the same methodology of transport layer. Finally, application layer operates with the session layer, presentation layer, and application layer. Next, now we see the concepts of wireless networks. So how it is initiated, it will be quite interesting. In 1874, Marconi experiments signals to send and receive using electromagnetic waves. So how he achieved is, see, he used 2 different points. So the obstacles of these points are overcome by sending and receiving the signals with 2 distinct points. So this is the basic methodology where the radio communication happens. So further, if we see, in 1901, Marconi set up a radio station in England. So so why he had set up that in, means with 3,500 kilometer. Uh, so it acts above the ionosphere layer. So why the ionosphere layer is, the ionosphere layers reflects the electromagnetic waves. So this is the foundation or fundamental to all long distance wireless radio communication. So this is the thing, in this diagram we can see how the communication happens above the earth. So in the earth, if we can see, there are wired communications are happening with the fiber optic cables, with the help of satellites, earth stations, microwave, and satellite communications are happening. So what is meant by a communication basically? It is nothing but process of sharing the data, programs, and information between two or more systems. So now coming to actual concept of wireless and mobile communication. So there are 3 types of wireless and mobile communications. They are simplex, off duplex, full duplex. We can say it is a mode of transmission mode of wireless and mobile communication. So simplex communication. So simplex communication works. The transmission is taking place in only one direction. So examples are so the transmit. So examples are that is it is the data are transmitted in one same frequency. Both the sender and receiver should have maintained the same frequency. So it is possible when the communication takes place in only one direction. For example, when we are typing the things in keyboard, the communication takes place in only one direction. Similarly, fiber optic cables, the communication takes place in only one direction. So this is a pager which was used by people a decade before. The pager, at a single time one can type and other can receive. At a single time only the one side the communication takes place. Next is half duplex communication. So half duplex communication, as we see in the diagram, the transmission is taking place either in one direction but not simultaneously. So this is the thing. So best example is walkie-talkie. So it is a two-way communication. As we said, it is a two-way communication system, but a subscriber can only transmit or receive voice transmission at any given time. So the same frequency is used between sender and receiver. So push to talk feature, that is push to talk feature with walkie talkie. This is the best example of half duplex communication. Next, if we see full duplex communication, transmission occurs in both the directions simultaneously. So this is the main advantage of full duplex communication. So the communication is bidirectional. What is meant by bidirectional? Bidirectional is the data flow in both the directions, right? The data is flowing in both the directions. Then both the stations can send and receive messages simultaneously. So it has two channels. So where one channel is used for traffic and other is for opposite direction traffic. So two channels are used. And compared to simplex and half duplex, it is the fastest mode of communication. So the best example of full duplex communication is the telephone network, which is uses two channels for communicating center side and receiver side. Next, we'll go through quick differences or characteristics of simplex, half duplex, and full duplex communication. So the direction in terms of direction, simplex communication uses unidirection, and sending and receiving we already saw. One time people can send, and performance it's very poor, least performance. Example is radio communication. Then half duplex communication. In half duplex communication, it is a bidirectional communication. Both the sender and receiver can transmit, but only at a single time one can transfer and receive. And performance is it is simplex, and it also can be used full duplex with the conditions applied one at a time. Example is walkie-talkie. Then in full duplex communication, both the sender and receiver can send the data at bidirection, both the directions. Both devices can send and receive simultaneously. It is the best performance compared to simplex and half duplex. The example is telephone network. I hope it is quite understandable. Next, so the elements of wireless communication. So elements means how the communications are taking place between sender and receiver. So what are the components are involved. So the information, so this is the source and this is the destination. So the transmitter transmits the data, and the channel will be there to transmit the data. So channel transmission medium. Then the receiver gets the data, and finally it is given to destination. The noise in the communication happens. So noise are getting transferred in the media. So these are the important elements of communication. So the sending and receiving devices. Examples are computers or specialized communication devices are used for sending and receiving. Then communication channels. The communication channel is nothing but the physical wire or cable. In wireless communication, it is Bluetooth or some other wireless mediums. In connection devices, so connection devices are communication devices. So it acts as an interface between sending and receiving devices and between the communication channel. So they are used to process communication between sender and receiver across the channel. Okay, they can travel. So it is used for traveling the information. Finally, the data transmission for specification. So what does it mean? It is the rules. Okay, rules and procedures that coordinate the sending and receiving devices. So this is about elements. Finally, we will see wireless communications advantages and disadvantages. So advantages are wireless devices are especially used for mobility purposes. Easily people can carry their devices from one places to other places. So the reliability also there with if it is safe and secure and easy installation. There is no need of any big hardware installation, lowest cost for installation, and it is used for rapid disaster recovery. The disadvantages are signal interference. So, for example, the long buildings heights like that or any climatic conditions, so the signals are getting interferences and security purpose. So people can easily tamper the data. Finally, the health hazards will occur if one is using continuous wireless devices for a long time. Thank you. We'll see you in next lecture. Hey all, in this video we are going to discuss various frequencies which are used for radio communication, that is which are used for mobile communication. Okay, so if we see, can see the electromagnetic spectrum which are given here. So the electromagnetic radiation is in the form of energy travels through the space. The electromagnetic energy spreads out in the form of visible light, radio waves, X, X, gamma rays, infrared rays, etc. The electromagnetic spectrum covers all the electromagnetic radiations arranged according to their frequencies. So you can see here each and every radio waves are arranged according to their frequencies. The frequency and wavelength are inversely proportional to each other. In the electromagnetic spectrum, the higher the frequency and the lower the wavelength. So further we can discuss the frequencies and wavelengths. So from this we can understand each and every electromagnetic waves are spreaded across with various radiations and frequencies. But why why we are having different frequencies for different channels? To understand this, we need to go through quick history. So that is it. To prevent interference, we already saw what is meant by interference in last lecture. To prevent interference between different users, the generation and transmission of radio frequency bands is strictly regulated by national laws. So the national laws, it is governed by International Telecommunication Union. So International Telecommunication Union, so which we can say ITU. ITU, which stands for International Telecommunication Union, so which follows the rule. The International Telecommunication Union, it is a mandatorily as a member of UN Development Group. So it coordinates and shares global use of radio spectrum. So it promotes international cooperation and in assigning satellite orbits, which works to improve telecommunication infrastructure in the developing world, and it assists in the development and coordination throughout the worldwide. So different parts of spectrum, that is radio spectrum. So radio spectrum we can say it is RF. So RF, R stands for radio, F stands for frequency. Okay, RF bands, okay, are allocated by the ITU for different radio transmission technologies and its application. Some various radios regulations are also given by this IDU. So radio regulations are denoted as RR. So only we need different frequencies for different channels. Hope you can understand everything. So next we will see spectrum allocations. As we already saw that, so different frequencies are used with different wavelength. So here we can see that either twisted pair cable or coaxial cable optical transmission medium are using for the communication. One more important thing you have to remember is, as I already told, the relationship between frequency. So frequency is denoted by F. The relationship between frequency and the wavelength lambda. So how we can denote it is lambda is given by C is equal to C by F. So what is C? So C by F. So now what is C? C is nothing but um, speed of light. So c is equal to c is denoted with the constant value, where you can say it is a 3 into 10 10 power 8 10 power 8 m by s seconds. So, according to this formula, that is lambda is equal to c by f, you can understand that. So the frequency and the wavelength are both are inversely proportional. So by using this, we can they have formed various frequencies: VLF, LF, very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, extreme high frequency, infrared frequency. This is visible light UV. So each and every frequencies will operate in particular hertz, 300 hertz like that. So still to be more clear, here in this diagram we can see the extremely low frequency. It is used. The extremely low frequency is abbreviation is given as ELF. The ITU band number is 1 and it operates in frequencies of 3 to 30 Hz. And this is used in communication with submarines. So this extremely low frequency, super low frequency and ultra low frequencies, these three are used in submarines communication and communication with mines. Then if we see the very low frequency, and important thing people need to note is the ITU number. As we already saw the ITU number, so International Telecommunication Union has formed a number for each and every frequency. So very low frequency is used with the ITU number 4 and it is useful in submarine communication, wireless heart monitoring, geophysics, etc. And the low frequency is abbreviated as LF and it is given the ITU number 5 and it operates in the wavelength 10 to 1 kilometer and it is used for navigation purposes and broadcasting purposes like that. Then medium frequency, it is given as MF and the ITU number is 6 and it operates with AM waves. Then high frequency is given the number as ITU band number as 7 and it is used with various radio communications and mobile communication, radio telephony like that. Next, if we see the very high frequency, it is given the ITU band number as 8 and it is abbreviated as VHF and the frequency range is 30 to 300 megahertz and the wavelength is 10 to 1 meter. Okay, and it is used in FM, television, broadcasting, etc. and weather radio things. And if we see the ultra high frequency, the ITU band number is 9 and it operates in the frequency of 300 to 3000 megahertz. It is used in various types of real life protocols like Bluetooth, Zigbee, GPS, like that. Then if you see the super high frequency, so the ITU number is given as 10 and the frequency is 3 to 30 gigahertz and the wavelength is 100 to 10 millimeter. So where it is used is it is used in astronomy, microwave devices, wireless LANs, like satellite radio communication like that. Finally, the extreme high frequencies are given with the ITU band number 11 with the frequency 30 to 300 gigahertz. It is used in microwave, remote sensing, wireless LAN like that. So, so here you can see a clear idea of how we saw with the previous slides. So here the wavelength is increasing in this side and increasing frequency is in this opposite side. So as we saw the formula, both the wavelength and frequencies are inversely proportional. So the very low frequency and low frequencies are used for maritime radio navigation and the medium frequencies and high frequencies with the gigahertz with the hertz means here you can see the frequencies ranges. Okay, So here you can see 3 megahertz, 30 megahertz like that. So these are used in AM radio, and if you see very high frequency, ultra high frequencies are used for television, FM radio with 300 megahertz. The super high frequency satellite communication, it is used with 3 gigahertz, 30 gigahertz. Finally, extra high frequency or extreme high frequencies are used for satellite and mobile communication. Hope everyone could have understand how the wireless radio communication is happening. So we'll meet further in next video. Bye. Thank you. Hi all, in this video we are going to discuss signals, noise and types of noise. So what is a signal? Signals are physical representation of data. So users of a communication system can only exchange data through transmission of signals. So this diagram represents the signals with sine wave. So signals for radio transmissions are represented with sine wave with amplitude, frequency and phase shift. So amplitude is the distance between central line to the peak. The frequency is number of cycle of a radio wave which completes in 1 second. The phase is represented as a location of a of any particle in a waveform in a periodic nature. So here the formula is represented as SFT is equal to AT is amplitude of a sine wave with the multiplied the 2 pi into ft of the frequency and psi t. So like that the signals are represented with this simple formula. So the wireless communication, how the wireless communication takes place with the signal. The wireless signals are important because they can transfer the information such as audio, video or our voices, data without any wires, which are very useful for real-time applications. Wireless signals are electromagnetic waves traveling through the air. So they are electric energy travel through a piece of metals. For example, a wire or an antenna. So in this diagram, an antenna is used for wireless signal to transfer from source to destination. So it depends on the strength of the energy of the signal which is being transferred. Then types of wireless signals. There are two types of wireless signal. There are frequency and modulation. So the frequency of the signal, it depends on the occupation of the spectrum. In previous lecture, we saw various spectrum with various frequencies. So the frequency of the signals is rate at which the signal vibrates. So if the signal, for example, if the signal vibrates very slowly, the signal vibrates very slowly, then we can say it is a very low frequency. If the signal vibrates very quickly, so we can say it is a high frequency. So based on the vibration, the signals are classified as low frequency signal or high frequency signal. So the frequency is measured in hertz. So for AM radio, the frequency is around 10 megahertz. For FM radio, the frequency is around 100 megahertz. For television, the frequencies are measured in between 400 megahertz to 800 megahertz. For cellular phones, the frequencies are measured as 850 megahertz, 1900 megahertz. For Wi-Fi, the frequencies are measured with 2.4 gigahertz as well as 5 gigahertz. The satellite communication works in 3.5 gigahertz. So the modulated signal. So what is modulation? So why we need modulation? This details with examples we will see in coming slides. But time being, modulation is needed for a wireless signal to transfer the information. So there are two types of modulation. One is amplitude modulation, another one is frequency modulation. So amplitude, we already saw, amplitude is nothing but the distance from the center line to the peak, and frequency is the number of cycle of a radio wave which completes in 1 second, right? Now we are going to discuss about noise. So noise is an What is a noise? It is an unwanted signal, or we can simply say it is a disturbance. So how the noise is occurring? So the noise is occurring during the transmission of the signal or while receiving the signal. Some unwanted signals get introduced in the communication channel, I- and which creates the receiver some unpleasant noise or disturbance, which degrades the quality of the communication. So this is known as noise, where it interferes the original message. It interferes the original message signal and corrupts the parameters of the message signal. So in this diagram, you can see the noise signal where the amplitude is quite varying here and there, and the noise signal, it is not in proper way. So previous slides we saw the signals with the proper sine wave, right? But here the noise is varying. Due to the noise, the signal's amplitude is highly affected. So there are various two types of noise are there. One is external and another one is internal noise. Now we'll discuss external noise. So external noise are caused with the effect of external sources. So the external sources, what type of external sources are affected by the noise? Or the noise is produced by external force due to irregularities and atmospheric condition. The noise cannot be completely eliminated. And extraterrestrial noise, so solar noise, cosmic noise, and industrial noise, these are known as external noise. Okay, external noise which are caused by external sources. Next type is internal noise. So internal noise is created by internal source. So internal source, so the internal source, the noise is produced by the receiver components while functioning. So it means in the circuits, due to some continuous functioning, it may produce some noise. The noise is quantifiable. A proper receiver design may lower the effect on the internal noise. So examples are thermal agitation noise. So thermal agitation noise, it is an electrical noise. It is also known as Johnson noise. Then it is a short noise or transmit noise, which is during transmission of a signal. Then miscellaneous noises. So what is miscellaneous noise? Miscellaneous noises are nothing but includes a flicker, resistance effect, and mixture generated noise like that. Next, we'll see examples and effects of noise. The noise, what will a noise can cause? A noise can cause many issues. The first example is hiss sound. What is this hiss sound? Hiss sound occurs in radio receivers. Then next thing is buzz sound. This buzz sound occurs in the telephone conversation, then flicker in television receivers like that. Not only that, the noise limits the operating of range of systems. Noise also are very sensitivity to receivers. Hope in this lecture everyone understood signals, noise and types. Thank you. Hi all, in this lecture we are going to discuss modulation. So what is modulation? So why we need modulation? Everything we are going to discuss in this lecture. So there are two important processes are used in data communication. They are modulation and demodulation. So what is the modulation? So why modulation is needed? So modulation is used in signal transmission of a distance communications. So without any interferences or noise, the signals are being transmitted from sender to receiver. The signals need to be undergone to a particular process called modulation. So it improves the strength of the signal without disturbing the other signals. So a high frequency signal can travel up a longer distance without getting affected by any external disturbances. So modulation superimposes a weak signal and a carrier signal, which is a modulated signal. So the modulated signal further improves to travel to longer distances. So why modulation? So the information in the signal need to be transmitted with low frequencies. This low frequency signal is a weak signal which cannot be transmitted over a longer medium. So in order to avoid that, we can provide some immunity to the signals. Like why immunity means the signal can be faded to due to various parameters such as light, noise, temperature, distance, pressure, and other physical phenomena. So in order to avoid all these things, the signal need to be undergone to a modulation process, right? So the modulation process, how it is being happened. So the information signal, a modulator, the information signal is carried with the help of carrier signal. So carrier signal doesn't have any information, it just carries your information signal, and finally the outcome is the modulated carrier signal. So this is the process of modulation, quite interesting, right? So what are the advantages of modulation? So the modulation reduces the antenna size. There is no need to deploy any larger antennas, and no need of signal mixing, because we are using a carrier wave which carries our information without any fading. Then increasing the communication range. So it is applicable for longer distance communications, and multiplexing of signals. So multiplexing of signals at a particular time, we can use various users to communicate over the signal, and bandwidth adjustments also given according to the application which the user is using, and it improves the reception quality with the. Now we will see signals in the modulation. There are various signals. That is basically it is three signals are available. One is message signal, carrier signal, modulated signal. So a message signal. So message signal is a signal which contains the original message to be transmitted. So it is the baseband signal which undergoes the process of modulation. Right. Next is the carrier signal. So carrier signal contains set in amplitude, frequency, and phase, but it contains no information. It is an empty signal, so which is just used to carry our message signal. Finally, the modulated signal is a redundant signal after processing the modulation. This is known as modulated signal. So this signal is a combination of modulation signal and a carrier signal. So these are the types of modulation. So what are the types of modulation available? There are two types are there. One is analog modulation, another one is digital modulation. In analog modulation, further it is classified as amplitude modulation, frequency modulation, phase modulation. In digital modulation, it is further classified as amplitude shift keying, frequency shift keying, phase shift keying. So here it is an example of amplitude modulation. Amplitude modulation, it is the amplitude is getting varied. In frequency modulation, here the frequency of the signal is varied, like low frequency, high frequency. In phase modulation, the phase is shifted. So here like 180-degree, like that the phase is getting shifted. And we'll see analog modulation. So analog modulation, under analog modulation, so what is analog modulation? The carrier signal is used for modulating the analog signal. In analog signal, three parameters are combined to make the modulation. One is amplitude, frequency, and phase. So amplitude, frequency, and phase. So the amplitude modulation, under the analog modulation, we are having amplitude modulation. In amplitude modulation, the amplitude of the carrier signal is varies according to the information signal. Here, the carrier signal remains. The remaining parameters are frequency and phase. These two remains constant, whereas the frequency is changed. So in amplitude modulation, so this is the amplitude of the signal, and this is the carrier signal. So here you can see the maximum amplitude according to the signal, and here we are having minimum amplitude according to the signal. So this is the amplitude modulated signal, right? So next is the mathematical expressions, like the modulated signal is denoted as m of t, and which is given with the cosine formula, that is am cos of 2 pi fmt, and the carrier signal formula is given as c of t ac cos of 2 pi fc of t. And when we are combining am and ac signals, and further the amplitude modulated signals are given as uh, amplitude signal which is added with the modulated signal, and the results are given as the final S of t. Right? There is a signal which we got. And then a modulation index is used. So what is a modulation index? Modulation index is used to calculate the level of modulation. So modulated level or modulated depth, how much it is getting modulated. So which is given by this mu. It is a mu is denoted with the ratio of AM and AC. So this is the modulation index for the frequency modulation. And how to calculate maximum and minimum amplitude wave modulation is with this help of formula. The maximum amplitude modulation is calculated with the carrier signal is amplitude of AC and AM, and then the minimum means we can add AC with AM, we will get maximum amplitude. And when we can calculate the minimum amplitude, so the minimum of AC with AC minus AM. So when we are adding these two equations, we'll get the carrier wave amplitude is A max plus A min divided by 2. That is what we are doing, AC plus AM plus AC minus AM. So these two will get cancelled, and finally we got the result as AC is equal to A max plus A min by 2. Like that, we calculated the formulas related to amplitude modulation. Now we are going to discuss under modulation. So under modulation, so in some signaling in transferring the messages, the modulation index it is fixed as zero point 0.5. The modulation index is zero point 0.5, but some signals are in under modulation where before it is less than zero point 0.5. Okay, it is less than 0.4. Those signals are, those modulation schemes are known as under modulation. You can see in this diagram the under modulated waves are given like this. In opposite, the over modulation, that is it is greater than 1.5. The modulated waves are greater than 1.5. So that is the phase shift. The shift occurs. The modulation index increases in the carrier waves, and the phase shift, here you can see the phase shift is occurring, and which causes lot of interferences in the modulation. So next is the double sideband, which are used in modulation. So which are used to carry a full carrier wave. So in double sideband, in the process of amplitude modulation, the modulated wave consists of the carrier wave in two sideband. That is lower sideband, another one is upper sideband. The sidebands are nothing but they are band frequencies which are containing the power which are lower and higher frequencies in the carrier frequency. The transmission of the signal is the transmission of the signal contains these two side bands which are double side bands in the carrier systems. In some cases, some transmissions, we need only a single sideband. A single sideband is a process of suppressing of one sideband along with the carrier and transmitting only a single sideband. So here in this diagram, the lower sideband is suppressed, only the upper sidebands are used to transfer the messages, like FC plus FM is used. So some applications need only one sideband. In that cases, this type of sidebands are used. The advantages, what are the advantages and disadvantages? The advantages using this amplitude modulation is, so the bandwidth or spectrum space is occupied lesser than the AM, and the transmission of the signals, more signals are allowed, and the power is saved, high power signals can be transmitted, noises are very much reduced due to the chord bands, and signal fading also less. But it has some drawbacks like it need to go on under various processes, various detection processes, and the quality of get signals are when we are using SSB transmitters, the quality of signals are very much distracting. And the applications if we see the application of this signals, it is used in various types of maritime applications, mobile communications, point-to-point communications, radio wave communications, televisions, telemetry, and military communications. Next is demodulation. So demodulation is nothing but extracting the process of baseband message signal, that is the original signal from the carrier signal, and which are interpreted by the intended receiver. So this demodulation is taking place in receiver side. So the modulation takes place in sender side, demodulation takes place in receiver side. Thank you. Hi all, in this lecture we are going to discuss multiple access technique. What is multiple access technique? Multiple access schemes are used to allow many mobile users to share their medium simultaneously with a finite amount of radio spectrum. So it is achieved with the help of duplexing, where the subscribers send and receive information simultaneously. The best example is telephone systems. Various types of multiple access techniques are available. There are frequency division multiple access, time division multiple access, code division multiple access, space division multiple access. So multiple access. So what in order to understand multiple access techniques, so we need to understand the bandwidth available. Based on the bandwidth available, there are two types of multiple access schemes are there. So the bandwidth plays major role while dealing with sending and receiving communication with multiple access technique. So the bandwidth we already saw in last lecture, the relationship between bandwidth and frequency. So bandwidth is the important properties for sending and receiving information in multiple access scheme. So there are two types of multiple access techniques available based on the need of bandwidth. So they are narrow band signals. So narrow band signals, if the signal is very small, that is the system can operate with the narrower coherence with the available bandwidth. So that is this is known as the narrow band systems. Next is wide band system. So wide band systems, the transmission of the bandwidth is much larger compared to narrow band. So the name itself we can understand, it is a wide band. The bandwidth is much larger. Next is the frequency division multiple access techniques. So how it is working. So frequency division multiple access techniques combines more than one signal over a common shared medium. So the total bandwidth is divided into frequency bands that which do not overlap. So if you see, the total bandwidth is divided into set of frequency bands. Like if it is a thing, the frequency, it is bandwidths are divided like this. So this is one bandwidth, and this is another bandwidth. In between the frequencies, there is a strip called guard band. Okay, it will be like this. So this guard band is used for preventing overlapping of the signals. So it prevents the overlapping of the signals. That is the main purpose of using guard bands in frequency division multiple access techniques. So if you see here the frequency division multiple access techniques, so input signals, we are having various input signals and output signals, and we are having frequency band 1, frequency band 2, band 3, band 4. Like a spectrum is divided into various types of bandwidths. In between this band 1, band 2, we are having a small strip which is known as a guard band. So guard band prevents the signals to overlap the signals with each other. This is the main advantage of guard bands. I hope it is understandable. Then finally, the applications of frequency division multiple access techniques. So frequency how it is being applicable in wired networks. Wired networks are using copper cable or fiber optic cable, and yeah, like best examples are telephone networks. In wireless networks, the frequency division multiple access schemes are applied with the help of cellular networks and with the help of satellite communications. That's all about frequency division multiple access techniques. Thank you. Hey all, in this lecture we are going to discuss frequency and phase modulation. So frequency modulation, the frequency of the carrier signal varies according to the amplitude of the modulating signal. So in this diagram, the amplitude of the signal is given here, and this is the carrier signal, and finally based on the amplitude, the frequency of the signal is also varying. So the frequency of the modulated wave increases when the amplitude of the message or signal is getting increased. The frequency of the modulated wave decreases when the amplitude of the modulating wave decreases. So the amplitude and frequency are directly proportional to each other. So if the frequency of the modulated wave remains constant, and it is equal to the frequency of the carrier signal, and then the amplitude of the modulated signal will be equal to 0. So if we see the mathematical expressions of the frequency of the signal, so it is given with ft. Ft is given with fc plus kf into m of t. So fc is carrier frequency, kt is the frequency sensitivity of the particular signal, and mt is the message signal. So when we are connecting it with angular frequency wt, the angle is represented as theta I of t. So it is given with this formula angular frequency with the differential equations d theta I of t by dt. And further, if we substitute value of wt 2 pi fi ft, then it is written like this. And finally, we'll get the equation of angle as 2 pi integration of ft dt. So if we further do the simplifications, the values of s of t, that is the signal value for a particular frequency, is given by this cosine formula. Then the modulation index, when we are calculating modulation index, it is calculated with the formula del f by fm. So del f is given with kf am by fm. So the difference of modulated frequency is carrier frequency is denoted with the frequency deviation. It is further denoted as del f, and which is equal to the product of kf and am, which we already saw what is kf, what is fm in previous lecture. Now in terms of phase modulation, the phase of the carrier signal varies in accordance with the instantaneous of amplitude of the modulated signal. So here the same diagram. So amplitude is there, and carrier signal of the amplitudes, and this is the phase change. So phase change and amplitude are both are inversely proportional. So the phase of the modulated signal has various points according to the phase shift. Right, so the modulated signal changes if the phase of the according to the phase of the signal. If the amplitude is positive, the phase changes in opposite direction, that is in one direction. If the amplitude is negative, then the phase changes in opposite direction. So based on the amplitude, the phase changes. So amplitude is positive, then the phase is in same one direction. If the amplitude is negative, then the phase changes in opposite direction. So the mathematical expressions are given with the phase changes are with psi I is kp dot mt. So kp is phase sensitivity, mt is the given message signal. So further, if we classify the values, the angle modulated wave is derived with the formula of ac cos 2 pi fc t into psi I. Then further, if we substitute psi I, this value, that is kp m of t, this is the value of the phase modulation. Then further, if we calculate modulation index of the channel, it is given by the formula del psi, that is kp dot am. So that is the phase modulation of the mobile communication is used in mobile communication, and the frequency modulation is used in FM broadcasting. Hope you understand the mathematical expressions of both phase and frequency modulation. Thank you. Hi, in this lecture we are going to discuss basics understanding of code division multiplexing. In code division multiplexing, it is a multiplexing technique which is used in spectrum communication. In spectrum communication, a large number of bandwidth of frequency is used across various channels with narrowband signals. So here the interference is very less because various codes are used for various channel, and it is a better secure compared to other multiplexing techniques. In this diagram you can see, so based on time and frequency, the channel is divided into various codes C1, C2, C3, C4, C5. So like various codes are assigned to particular channels, and it is used with narrowband frequency. And if you see, in each communication station is assigned with unique code. So while assigning a code a station, if a code is multiplied by a code with another station, it yields to 0. If the code of one station is multiplied by itself, and if it provides a positive number which is equal to number of stations in that communication link. For example, we can see here, assume there are four stations which are named as W, X, Y and Z, and these stations are assigned a codes CW, CX, CY and CZ, and they need to transmit the data DW, DX, DY and DZ respectively. The communication channel is given with this formula, that is dw.cw. So dw is nothing but a code, and cw is dw is data, and cw is a code. Similarly, dx is the data of a station X, and cx is the code of station X, and plus dy is the code data of station Y, and CY is the code of station Y. Similarly, DZ dot CZ. Likewise, the codes are multiplied between the stations. And in code division multiplexing, it uses orthogonal sequences. So orthogonal sequences in the sense they are carefully generated with the chip sequences. So a sequence with either the sequences are comprised either with +1 or -1, and this holds certain properties where the interferences are getting avoided. And here if you see, the sequence is multiplied by a number and all elements are multiplied by that number, or we can say the multiplying with two sequences which corresponding positional elements are multiplied and summed to give the results. So if the sequence is multiplied by itself, the result is m. What does this means? It is a number of stations. If a sequence is multiplied by another sequence, then the result is 0. And adding two sequences, we add the corresponding positional elements. So they can be easily identified with these examples. So consider there are four stations W, X, Y and Z, and here we are having this sequence. So if +1 -1 -1 +1 is multiplied by 6, then we get +6 -6 -6 and +6. Then if is a sequence and it is multiplied by itself, and the answer is 4, which is equal to number of stations. We had 4 stations, and if this is a sequence and this is multiplied by another sequence, we get the result, means another sequence, and it will we get the answer is 0. And if we want to add a sequence, we get answer like this, that is +1 +1 -1 plus 1 a plus 1, that is 0, and then -1 plus -1 it is -2, and +1 plus -1 it is 0. That's all. Thank you. Hi, in this lecture we are going to discuss time division multiplexing. So time division multiplexing, it is a digital multiplexing technique. So in time division multiplexing, the channel or link is not divided based on the frequency or phase, whereas in time division multiplexing, The time is available time is divided across the channels between sender and receiver. In time division multiplexing, the sending device takes control of entire bandwidth for a particular amount of time. In time division multiplexing, the data rate capacity of the transmission medium should be always greater than the data rate required by sending and receiving devices, because at a particular time both sending and receiver devices will utilize the channel, and the capacity should be more. In time division multiplexing, each signal will be transmitted for very short time. So in time division multiplexing, each channel can be used either analog or digital signals, or it can be a digital signals. So the frames transmitted on the common communication medium is based on the time. So here we can see three devices are there, both sender side and receiver side, A, B, C. So these three devices want to send and receive data. So both sender side and receiver side we are having multiplexer, and in receiver side we are having demultiplexer. The sender at particular time A is sending a frame A1, and B is sending a frame B1, and C is sending a frame C1. Similarly, at next time slot, A is sending a time frame A2, and B is sending a time frame B2, and C is sending a time frame C2. And then A is sending a time frame A3, and B is sending a time frame B3, C is sending a time frame C3. Then these time frames are sent to multiplexer, and in channel they are traveling according to the time slots how they had sent A1, B1, C1. And in demultiplexer side, the receiver gets the data as how it is sent. So there are two types of time division multiplexing available. One is synchronous, another one is asynchronous time division multiplexing. In synchronous time division multiplexing, each device is given a same time slot and over the channel to send and receive data. And the synchronous time division multiplexing, the total speed varies with the input lines, and the input lines should not exceed the capacity of the path. So input lines and capacity of the path should be maintained properly. Each device is its data onto the link. When it is time slots arrives, each device is given a particular line in turn. If any device does not have any path to send data, then it remains empty. So the various time slots are organized into frames, which are showed here in frame. So if this device data is organized like this, if there are n sending devices, there need to be n slots in the frames, one slot for each device, and it is the data are sending frame by frame. So the disadvantage is the channel capacity cannot be fully utilized. How? For example, if there are 10 channels available and in the particular time frame we are using only 5 lines, that is 5 frames are utilized, then remaining 5 frames are wasted. The capacity of a single communication line is used to carry various transmission, which should be always greater than the total number of input lines. And next is asynchronous time division multiplexing. It is totally different from synchronous time division multiplexing. In asynchronous time division multiplexing, time slots are not fixed, that is, the slots are flexible. The total speed of input lines can be greater than the capacity of the path. So in asynchronous time division multiplexing, if we have n input lines, then there are n slots in one frame. That is the slots n slots and are m slots. It should be m less than n. So m is noted as number of slots and n is input line. Always m, that is the frame should be less than the available input lines. In asynchronous time division multiplexing, the time slots in a frame is the statistical analysis of the given inputs. So here we can see 5 devices are there and we are having 3 frames. So based on the necessity, the devices are given the frames and the data is getting transmitted between sender and receiver. Here only one side is shown. As we already saw, the multiplexer scans the various input lines and accepts the data frames and then sends the frame across the link. If there are not enough data to fill the slots, then the frames are transmitted partially filled. And in asynchronous time division multiplexing, there are three scenarios or three cases are there. The first case, with the sender, according to the previous example, five devices. So five input lines placed on the data link. That is the number of input lines and number of slots per frame are same. Both five input lines and five slots. In the next case, 4 out of 5 input lines are active. Here the number of input line is one more than the number of slots per frame. Finally, all 5 input lines are active. The advantages and disadvantages of TDM are: in advantages, the full available channel bandwidth can be utilized for each channel, and intermodulation distortion is absent, and the very complex circuits are not needed for TDM, and the crosstalk is very less and it is somewhat secure. In disadvantages, synchronization is needed between sender and receiver if it is a synchronous time division multiplexing, and it uses narrow band fading where the channels may get wiped out at a particular time. Thank you. Hey all, in this lecture we are going to discuss cell sectoring and cell splitting. So the cell splitting is the process of subdividing a congested cell into smaller cells. That is, there is a base station and the corresponding reduction in the antenna height and the reduction in the transmitted power will be properly utilized within the station. The splitting the cells is needed, which reduces the cell size and can have more number of cells can be utilized. If the more number of cells are increased, more number of clusters are increased, and the more channels will be there, which will provide higher capacity to each users. So the cells are split to add the channels with no new spectrum usage. And depending on the traffic pattern, the smaller cells may be activated or deactivated based on the use of resources. So this is a large cell, which is the first thing is a larger cell, and the second thing is a smaller cell, and it is the smallest cell which is inside the cell. So larger, small, and small. So the examples are a city. A city can be placed as a radio cell plant. Different cell sizes and different clusters are utilized. In this, a given city is divided into seven cell sector, and here it is a very smaller cells. And here this is a total number of 12 sectors, 12 cell sectors, and it is a cluster of 7 cell clusters, and it is a 4 cell clusters. Likewise, based on the need of the particular area, the cells are utilized for cellular radio communication. And here another example, the requirement of the higher capacity. This bigger cells are further divided into smaller cells. Smaller cells are based on the particular necessity. Now the topic is cell sectoring. In cell sectoring, as opposed to cell splitting, in cell sectoring we are concentrating on D by R ratio. D is nothing but co-channel radius between two channels, the distance of the two co-channels, and R is the radius of the channel. This D by R is kept constant while decreasing the R. Sectoring keeps R untouched and reduces D by R. The capacity of the sectoring is improved by reducing the number of cells per clusters, thus increasing the frequency reuse. In order to do this, it is necessary to reduce the interference without decreasing the transmit power. So how it can be achieved? The co-channel interference (CCI) may be decreased by replacing an omnidirectional antenna by several directional antennas, where each radiates within the specified sector. A directional antenna is used to transmit and receives from only a fraction of the total number of co-channel cells. Thus, the co-channel interference is reduced. A cell is normally partitioned into either three 120 sector or four 90 sectors or six 60 sectors. So here we can see it is the omnidirectional, that is only one channel is there, three 120 sector is there, or the 90-degree sector, that is four channels are there, or six 60-degree sectors are there. The sectoring is divided according to the necessity of the particular area. So in cell sectoring, the transmitter antennas can be placed in the corners where the adjacent cells meets so that the interference can be avoided. I hope people understood this cell sectoring and cell splitting concept. Thank you. Hey all, in this lecture we are going to discuss medium access control. So medium access control. In medium access control, we are having two issues. So they are hidden and exposed terminal problems. In hidden terminal problem, a sender here, assume we are having three nodes, three mobile users using mobile phone. A sender A wants to send message to B and C cannot hear it. At the same time, C wants to send information to B. C senses the medium is free. Collision occurs at B because both A is sending message to B and wants to send the message to B. So this red line in this red circle indicates collision is occurring at B. So A cannot receive the collision. Since collision is at B, so A cannot receive the collision. Hence C fails and C is hidden from A. The C is hidden from A. This is known as hidden terminal problem. Next is exposed terminal problem. Assume a scenario where B wants to send to A and C wants to send to another terminal which is not in the range of ARB. C has to wait because the signal it senses that the medium is in use, but A is outside of range A. So A and C are not in the range. Even though they are not in the range, waiting is unnecessary for C. So this means that C is exposed to B because A and B are communicating each other. So unnecessarily C needs to wait. Assume here another station is there D and C wants to send to D, but since the medium it identifies it is busy, C cannot able to send to D. So this is known as exposed terminal problem. Another more problem is there which is known as near and far terminals. Terminals A and B want to send each other. Okay, one are sending and C receives it. So signal strength decreases proportional to the square of the distance. So this is the general scenario about the signal. B's signal drowns out of A's signals. So C cannot receive A. So this is this problem with near and far terminals. So B is far away from A. If C was an arbiter, B would drown out A. So also severe problem for collision detection multiple access networks occurs with precious power control needed. So these are the problems occurs in multiple access collision avoidance schemes. So here we are having further access methods: SDMA, FDMA, TDMA, space division multiple access, frequency division multiple access, time division multiple access. Space division multiple access, it uses spaces into sectors, which uses directional antennas which are applicable in cell sector. Then frequency division multiple access assigns a frequencies to a transmission channel which is the permanent frequency is assigned for a particular channel. So either it in case of radio broadcasting, or it is a slow hopping in GSM, or a fast hopping in frequency hopping spectrum. So in time division multiple access, a particular time sequence is allowed between sender and receiver, and both will transmit the data within the particular time amount. So here example of frequency division duplexing with FDMA general scheme example in GSM. Here we are having a base station, and here the uplink and downlink frequencies are given here. So the downlink frequency is 960 megahertz, and here one more frequency 890 megahertz. So the frequencies are allotted for a particular channels, and the communication takes place between base station to mobile nodes using GSM. So the frequencies are allotted for the particular frame. So highest frequency is given here. 935.2 megahertz is given for this free to this channel, and 915 megahertz is given here. Like that, the channels are given based on the time domain, and the frequencies are allotted in y-axis, and thus the communication takes place. And here also one more example. Here the base station is there and mobile node is there, and so the downlink frequencies and uplink frequencies are allotted by the particular channel, and it is communicated accordingly. And these are operated in 417 microseconds. Likewise, the frequencies are allotted for uplink and downlink communication. Next is aloha or slotted aloha, which are used in this MACA. So here the concept is, it is a random access mechanism. That is, there is no any central authority to control the channel. The slotted aloha use particular time slot sending and receiving the data. So here the aloha at a particular time slot, sender A, sender B, sender C is sending. So sender A is sending this message. So assume it is a message in the particular time slot. Likewise, sender B is also sending a message. Sender C starts sending, and see here collision occurs. In this place, collision occurs. Since there is no particular central authority to control, the collision occurs here. In slotted aloha also, the sender A starts sending the message, sender B sends the message, sender C sends the message, and here in particular place, the collision occurs in aloha and slotted aloha. So the DAMA multiple access scheme, that is demand assigned multiple access scheme, the channel efficiency need to be increased. In Aloha, the channel efficiency is 18%. Why? Because there is no central authority to control the channel. Anytime the collision can occur. In slotted Aloha, even the channel it is slotted, only 36% efficiency is achieved. In order to overcome that, the reservation mechanisms are happening. Like in railway reservation or aeroplane reservation, the reservation takes place. Likewise, in demand access, multiple access, the reservation is achieved and the channel efficiency is increased at 18%. Here the sender reserves the channel for the future time slots. Sending within the reserved time slot is possible without collision. This is obvious. Whenever we are reserving, we will be having a happy journey in aeroplane or in railways. So reservation also causes higher delays because it will take the channel to wait for a long time. The example is satellite communications. So in this reservation schemes, we are having two types of reservations: explicit reservation and implicit reservation, and reservation based on TDMA. So we'll see one by one. So access method DAMA, explicit reservation. So explicit reservation has two modes. One is Aloha mode for reservation. That is, the competition is among between small reservation slots and collision may be possible. So here the small reservation slots need the particular slot, so collision occurs. So it is important for all channels to keep a reservation list consistent. So reservation example, for a railway reservation, if the seat number 21 is needed by passenger A, and the same seat number, like we can say it is a window side seat, so window side seat is needed for both the passenger A and passenger B. So what happens, the collision will occur even though the reservation is there. So the reservation list should be contained precious. For example, A can have seat number 21 and B can have some other seat, say 31, like that. So it should be a consistent one between the sender and receiver. Thus all stations have to synchronize periodically in order to have the reservations without collision. Next, we can see access method DAMA with packet reservation mechanisms. So in packet reservation mechanisms, a certain number of slots form a frame which are repeated. Each station competes for empty slots which are used in slotted alpha. Once the station reserves a slot successfully, that slot is assigned to the station in all following frames, and as long as the station has data to send. Competition for a slot starts again once the slot was empty in last frame. There the channels are competing for an empty slot. So for example here, the reservation, so this 5, so here this the same slot is needed by this frame 3, then the collision occurs for the particular reservation slot. Next is reservation with time division multiple access. That every frame has a mini slot. So here the frame has some n mini slots. So which are given like this. So this is the mini slot, this is the mini slot, and X data slots. So these are the data slots. So every station has its own mini slot and K data slot. So this is the mini slot and this is the data slots. So how it is given is the data slots are given with this formula n star k. So other station can send the data in unused data slots according to round robin scheduling. On round robin scheduling, so each and every channel is given particular time, and in that particular time it will occupy the channel. Then once the time slot over, the next channel will come. Likewise in round robin scheduling, using this formula, the reservation takes place for a particular time slot, right? Then in Maca we saw four problems, that is near and far terminal, exposed and hidden terminal. So how these are avoided is with the help of RTS and CTS frames. The RTS is nothing but, so it is a multiple access collision avoidance scheme, so which uses short signaling packets for collision avoidance. So what is this short signaling packets? They are RTS CTS packets. RTS is R stands for request to, S stands for send, and C stands for clear to send. So here yes, in RTS, a sender uses RTS packet to request right to send before it sends a data packet, that it can be sent or not. Then in CTS, clear to send, the receiver grants a right to send as soon as it is ready to receive. So these are signaling packets which are used, which contains the sender address, receiver address, and the packet size. With the help of this packets, this problem of hidden terminal and exposed terminals can be avoided. Here A and C wants to send data to B. A also wants to send data to B, and similarly C also wants to send data to B. So initially A is sending the message RTS request to send. Then C waits after receiving CTS from B, just clear to send, till that C will be waiting, hence no collision will occur. So similarly in exposed terminal problem, B wants to send data to A and C wants to send other terminal. So in this case now C does not have to wait for it, because it cannot receive CTS from A, clear to send A. So the problems are getting solved here with the help of RTS and CTS packets. And one more strategy is used with the in Mecha is polling mechanism. Polling mechanism is achieved with the help of randomly addressing pooling. So if a base station want to poll channels for sending and receiving data, the first thing can be done is with the help of random addressing pooling. A base station signals to all mobile terminals. So assume there is a base station, and that base station signals, okay, the base station signals all the mobile stations, the terminals ready to send and transmit random numbers without collision using code division multiple access or frequency division multiple access. The base station chooses one address for polling from the list of all random numbers. So the base station is the authority which decides to whom it can communicate, to which mobile station it can communicate. The base station acknowledges correct packets and continues polling to the next terminal. This cycle starts again after pulling all terminals in the list. So the base station maintains a list, right? So from the list it has to give priority to all stations which are requesting. Likewise, the randomly addressing pooling uses to send data from base station to mobile stations. Next is inhibit sends multiple access. In inhibit sends multiple access, the medium is signaled via a busy tone. The base station signals on the downlink, that is base station to terminal. So this is the base station and this is the terminal. So base station to terminal, the signal is sending and it is checking whether the medium is free or not. The terminals must not send if the medium is busy. So if it has something here, it is doing some other work, then the terminals must not send a medium. It means must not send if the medium is busy. They won't send any reply to the base station. Terminal can access the medium as soon as the busy tone stops. Okay, okay, if it is over means then it can communicate. If the medium is busy means it cannot communicate, right? And so this is the mechanism is used in inhibit sense multiple access. Here it uses a busy tone to communicate between base station and receivers. Another scheme is CDMA, code division multiple access. Code division multiple access, all the stations will be given a particular code to transmit. Each sender has a unique random number and it does the XOR operation with the particular mobile station. So the disadvantages of this scheme are it is highly complex and all signals should have the same strength at the receiver. Advantages are it can use same frequency and huge code space is available and no interferences are very much reduced and it is very easy for error correction and encryption is easily available. Example is given here. Sender A is using sending AD as 1 and a key, okay, and a key AKS like 010011. Here we are assigning 0 as -1 and 1 as +1. So the sending signal is calculated with the formula. Okay, AS is equal to AD star AK. So AD star AK. Now the sender B, so BD, it is BD is the key is 0 and bk is the key with those values. The sending signal, the formula, same formula, that is bs is bd star bk. Now both the signal superimposes in phase. Interference may be neglected with the noises. And now when we are adding as plus bs, so we got this value. So -1 plus -1 -2 and +1 +-1 is 0, like that. The values are getting added. Now the receiver wants to receive the signals from sender A. So now it applies the key bitwise, that is inner product. So inner product of this key, that is A is equal to, and we have this key and dot AK. So AK is AK, it is a value with this key we here we are having. So when we are doing inner product, we got the value as 6. Similarly, receiving B also, that BE we got this value, dot BK we are having this value. When you do inner product -1 dot 1, like sorry, -2 dot 1 -2 it's coming, then if you do the addition you get the value -6. That is both are that is 0. So both are having the final value, it is a 0. Likewise, it is the communication is happening. So here in SDMA, TDMA, FDMA, CDMA, we are going to see the basic comparisons. So in SDMA, it uses space to communicate. In time division multiple access, the sender and receiver uses particular time slots and it is based on demand driven. Whereas in frequency division multiple access, the frequency of the particular channels with subbands are used. In code division multiple access, we are using orthogonal codes, which we saw in previous example. Orthogonal codes, we received sender side, we received +1, and receiver side we received -1. in terminals in SDMA, that only one terminal can be active in one cell or one sector, whereas in time division multiple access, in particular time slot, all terminals need to send and receive message with the same frequency, hence all terminals are active. In frequency division multiple access, every terminal has its own frequency which can be uninterpreted. In code division multiple access, all terminals can be active at the same time, same place and same moment, which is uninterpreted. Only codes are getting changed. In signal propagation, in signal separation, in space division multiple access, a particular cell structure is used and directed antennas are used to send and receive data. In time division multiple access, synchronization is needed for a particular time domain. Particular time domain, if you are using synchronized TDMA, then the synchronization is needed. In FDMA, particular filtering techniques are needed to send and receive data between sender and receiver. In code division multiple access, we are using code. For example, XR codes are used between both sender and receiver. The advantages in space division multiple access, it is very simple, and it increases the capacity per kilometer. In TDMA, it is fully digital, okay, digital, and it is flexible. FDMA is simple and robust. CDMA is flexible and soft handover. So handover between particular base station to mobile station, like that. The drawback of SDMA is inflexible antennas in terms of antennas and particular scenarios. It is not flexible. Whereas in TDMA, the God space needed, we saw already God space. The multipath propagation synchronization is very, very difficult. It need to travel multipath. In FDMA, it is inflexible because the frequencies of particular stations need to be maintained between the mobile stations. And in CDMA, it is very complex to have a particular course, maintaining of course with base station to receivers, or from sender to receiver. The maintaining of codes are very, very difficult, and power control need to be maintained. So SDMA, it's a combination. It can be a better if in combination with TDMA, FDMA, or CDMA. The TDMA, it is a standard things. It is better. It works better with the help of FDMA or SDMA. The FDMA is very much properly provides the communication between sender and receiver once it's working with the TDMA and SDMA. Finally, the code division multiple access can be integrated with TDMA, FDMA for better solutions. So thank you. Hi all, in this lecture we are going to discuss global system for mobile communication. So what is GSM? Everything we will discuss in this lecture. So GSM is a globally accepted standard for digital cellular communication. GSM stands for Global System for Mobile Communication. So it is used for voice and data services. So GSM uses the mobile phone technology in various continents and countries all over the world. So introduction to GSM. In introduction to GSM, GSM is emerged based on cell-based mobile radio systems, and it was done by Bell Laboratories in early 1970s. So GSM is the name of the groups which are standardized in 1982 by European Mobile Telephone Standards. Then GSM is most widely accepted standard in telecommunication systems, and it is implemented globally. Then in introduction to GSM, so GSM is a circuit switched device which has 200 kilohertz channels into 8 to 25 kilohertz time slots. So GSM operates in mobile communication with the bands 900 megahertz to 1800 megahertz all over the world. In GSM, it operates in 850 hertz to 850 megahertz to 1900 megahertz. So GSM is all over the world. GSM owns the 70% of the old market. GSM uses time division multiple access techniques which are used for transmitting signals all over the world. So these are the basic terminologies people need to understand how GSM is working. Like BTS is base transceiver system station, and BS is base station controller. Like various methodologies are there. These two slides are explaining the base methodologies. Next is how GSM is working. GSM needs base transceiver station module to communicate with mobile device. So the mobile device can change base transceiver station. It is like a base station. So GSM provides the frequencies band of 900 megahertz to 1800 megahertz. So in this diagram we can see a GSM network. As we already saw, GSM network, it needs a BTS, like here base transceiver systems. Here it is having a BTS, then here it is having a base station controller which is used for control the mobile devices, and the mobile switching station. So MSC, mobile switching center is there, and here we are having a HLR, that is home location register. Then here it has a signal transfer point. STP is there to transfer signals from one base station to another, that is base transceiver station to another base transceiver station. Then we are having MGW, media gateway. Through the gateway only, from one operator to another operator, the information is going and coming. Next, it is having various type of devices like uh, SMSC. So SM is short message service center. SMS, what we are sending and receiving, and then here it consists of various informations like IMEI and MSSIDN, like various informations are there. So likewise, also all the modules are integrated with an operator. So whenever an operator moves from one station to another station, the informations are sharing between the people. So this is a mobile device. So what are the components of a GSM? So mobile device, it is a wireless transceiver module. So which is used to communicate with the base transceiver station, and both voice and data are communicated with the mobile devices. So several types of mobile devices available based on 2G, 3G, and 4G, 5G, like that. So based on the current development, various types of mobile devices are available nowadays, right? So 5G mobile devices, like this, various types of mobile devices are there. Then base transceiver station. In base transceiver station, it is a wireless transmission, so which is used to receive the signal from terminals. So all mobile devices connected are should be nearest with the base transceiver station. So a group of base transceiver system connected forms a BSC. So BSC, it is not, it is base station controller. So base station controller is used to group base transceiver stations. So each BTS has an identification number. Then based on this number, based on the necessity, it can form the particular cells, and the antenna will cover the message. Like each and every cell, the messages are used to transfer. Then base station controller. The base station controller, it controls BTS. So BTS, these are base transceiver station. So it controls BTS. So BTS can be connected with using various types of microwaves or optical fiber. So this base station controller disconnected with and signal, and it uses mobile devices to hand over from one operator to another operator. So this place the base station controller take care of the handover. So handover is nothing but from one operator to another operator. The mobile devices are moving, all the informations are transferred. So what are the informations are transferred, that we will see in next lecture. So the radio network is managed with the frequency, what type of frequency user is using, those are controlled by the base station controller. So next is the mobile switching center. So mobile switching center, it is a large network which consists of small networks. The mobile switching center is related with the switching of mobile devices, call establishment and releasing of call. This mobile switching center, it is a control group of all base station controller. So base station control, like that, it controls all the base station controller. So when we are operating in large GSM network, this mobile switching center is connected with the STP, that is signal transfer point, which is used to route the signals, and media gateway for voice switching. So these mobile switching center plays a major role for routing and switching the data. And next is home location register. Home location register is a central database which has details of mobile subscribers. So each subscriber will be given a ID number, like it is the address of a user. So home location register is the address which has the users, which is a central database. It contains all the informations of the user who is communicating like that. Then visitor location register. In visitor location register, so whenever it is a subscriber database, so like subscribers details information. So visitor location register will be faster than HLR, because a visitor is traveling and he is moving from one operator to another operator. That visitor information will be maintained in this register. So suppose we are traveling from one place to another place in car. So that time this visitor location register will be maintaining the all the communications. So next is signal transfer point. So signal transfer point used to route the messages with the help of GSM signals. It is a signal endpoint and it used to route the messages between the various visitors. Then media gateway, it is a circuit switching network which is the IP gateway, and it is a format, it consists of the various formats, and it is used to send and receive messages with endpoints. So it is also known as soft switch in media communication. Next is equipment identity number. Equipment identity number, it is also central database which has the IMEI number of a user. So each user has some IMEI number, that is International Mobile Subscriber Identity Number, IMEI. So it is configured with equipment identity register. So that register and for any subscribers, this IMEI number is listed in the equipment identity register. So by using this only, sometimes if the mobile phone is missing, so this IMEI number and this EIR register, it can be easily identified the missing mobiles like that. Then is this EIR, that is equipment identity register, is used to prevent stolen or unauthorized mobile device use. So when somebody stole the mobile phones, with this help of this EIR and this IMEI, it is used to get the informations. Then short message service center. Short message service center is a node where the users are sending and receiving messages each other. Then unstructured supplementary services, various types of pop-ups are getting each and every time, like many messages are coming. These are handled with the help of unstructured supplementary services. Then mobile subscriber ISDN number, MSISDN is a unique number for every mobile subscriber. So it is in this format, that is country code, which country he is using, and then national destination code, and then NPA numbering panel area and SN subscriber number. So it is like this is the sample where it denotes the country code, national destination code, numbering, planning area, and subscriber number. Then subscriber identity model. This is a SIM. So SIM is various types. Everybody are using SIM with mobile. So like mini SIM, macro SIM, and nano SIM. Then it is an international mobile subscriber identity. It is a SIM identification number which is registered with home location register. So it is mapped with the particular registers which are used. And finally, this IMEI is a universal unique identity number which will be having 15 or 17 digits with the checksum to detect some errors or stolen things. This IMEI GSM network can be used to lock the devices. So like we can enter some hash slash based on the service providers. These numbers will be differ according to the record. I hope everybody could understand the basics of GSM. So this is the origin of the GSM things. Later it is established more. That advanced concepts we'll see in next video. Thank you.